so a new processor coming out. Here is Intel announcement, of the new processor, the proposed specs. So I want to make sure my RAM, I don't have to change my RAM again the next year when I upgrade my processor. With justification, it's okay. Okay? So I'm just going to give you an outline today of the PC spec design project. So we have been kind of ramping up to this project for the past 2 or 3 weeks, and most of the classes I have recorded, so you can actually go through the past notes, all the stuff that we have talked about, and pick out details that you need in order to get this done. Okay. So the purpose of the project. It's always important to state the purpose of a particular article or something that you're going to write. In this case, it is an assignment. So it is important for me to state that first so that you guys know what it is for. Okay? Several things. Design or specify a personal computer to suit a particular need, meeting particular criteria. Okay? Does everybody understand the difference between a need and particular criteria? Okay? Or I should make it to fill a Okay, so we have objectives and criteria. Objectives and criteria can be conflicting. In other words, I want to design a super duper game system. Okay, that's my objective. That's what I want the system to be able to do. Or I want to build a VMware server system that can run 16 virtual machines all at the same time. And the virtual machines cannot interfere too much with each other. One virtual machine taking up all the processing time allocated to that virtual machine will not impact the rest of the virtual machines. That's design. That's objective. That's what I want to use the system for. The criteria may conflict with that because I only have a budget of $300. Okay, or I want a system that I can put in my backpack. Okay, so those are criteria that will basically say, no way, we cannot make a system that can fill the objectives, but also fulfilling the criteria all at the same time. Okay, so I'm going to give you guys some examples here. Okay, examples of objectives. Okay, a gaming system that can run certain games at certain resolutions at certain frame rates. Okay, so I don't want people to just say, I want a gaming system. Well, I can game using my netbook too, just not a whole lot of games. I get 2 frames per second. Right? I see the bullet, I see the projectile here, and then I'm dead. Or I just see the flash of the opponent firing a weapon, and then I'm dead. I don't see anything at all, and then I'm dead. Okay? So that's why if someone wants to say, I want a gaming system, it has to be a little bit more specific than that. Okay? I want to run this game that is really hot right now, and I want to run it at a particular resolution. My HD TV supports 1080p. I'm going to play my game on my TV, 1080p resolution. And I want to run it at least 60 frames per second because that makes sure that I cannot tell the jagginess of the motion. Okay, so those are good numbers to start with. Virtual machine server that can run X virtual machines at the same time, each having 1 core dedicated to it, using up to a certain amount of memory. Okay, so once again, these are very specific numbers that tells me what I need or what the system is going to accomplish. Okay. Are there any questions at this point? Or someone can say a home desktop that can run CS5, IE, Firefox, whatever, Microsoft Office, and let's see, what else do you guys run on the regular desktop system?
Movie Maker.
Tetris.
I do a lot of Movie Maker.
Movie Maker.
Photoshop.
And Watch. How about Watch? WATCH. Watch, Hulu, or Netflix. Okay. So specific things. Okay. At the same time. Okay. Any questions about this stuff here? Okay. And then the next thing has to do with criteria. In other words, criteria are limitations. They are not things that you want to accomplish. It is basically restrictions that you have to play by, because there's only so much money that you can spend. Okay, so you can basically say, I have a budget of, X amount of dollars. It has to be silent. If you're putting a home theater PC together, you don't want to use 20 80 millimeter fans to cool the system down, because all you can hear will be just the buzzing of the fans, right? So in that case, you have to specify a special case with special fans that are quiet, or even special hard drives. Some hard drives are particularly noisy, so you have to kind of read the reviews of people and say, okay, is this hard drive particularly noisy?
Would you also have to consider the power supply for noise?
Yeah, some power supplies are.
I know some power supplies will make high-pitched frequencies that certain people can hear and others can't.
The case sometimes can deal with it, because or if you put the entire PC in a certain enclosure, high-pitched noise is easy to to mute. Low frequencies are much more difficult to deal with. So the vibration of a hard drive is actually worse than the high-pitched noise coming out from the power supply. Unless you have a dog. Yes, yes. A young one. Yeah, old dogs, cannot hear the high frequencies anymore. Just like people cannot hear, high frequencies, either. Yeah, I remember that. My students were playing that trick on me one day. They were just playing it behind me and go like, "What? That's noisy." And they were just startled. They were surprised that I could hear that noise. They were thinking, "Hey, you're kind of old. How can you hear that?" So you have budget, silence, maybe a particular size, because you want to fit the computer into a particular place. So you cannot have a full-size tower, to do something. Storage space. Okay, because if you're putting a home theater PC together, that determines how much stuff you can store before you have to watch something, or something starts to roll off the recordings mechanism, and etc. So I want these things all be specified by numbers. Okay, it's not just quiet. Tell me what is the decibel rating that you want. Okay, decibel is a measuring unit for signal to noise ratio. So that's one thing you can specify, is to use that. Okay, so the first part is the. Okay, so I just talked about objectives and criteria. Okay, so the next part deals with the actual construction of the PC. Now, when you specify the PC, or when you think about putting a system together, you can even order something from Dell. That's fine with me, but you have to explain why you pick this specific model and why you pick these specific options. So everything has to be rationale. There has to be a rationale and explanation of every decision-making point. Okay, so I always start with the processor. Okay, and what are some of the criteria of selecting the processor? Okay, socket type, how much money, number of cores, gigahertz, manufacturer, power consumption, heat dissipation, how much heat is the processor core going to generate, and as a result, how big of a fan you need to keep it cool, and so on and so forth. With each one, some of these have other considerations. When you select a socket type, you can select a socket type that has many different processors that will fit the socket type. And that makes this particular socket type flexible, because you can buy a $100 processor today and upgrade it later on, like next year, and get something a lot more fancy, but you don't have to throw everything else away. Okay? Number of cores, we talked about that. It may help. It depends on the application of what you're going to use the system for. The gigahertz, for me at least, is meaningless. Okay, that is really meaningless, because how fast your system can work is determined by many other factors other than the gigahertz. Manufacturer, that basically ties into socket type as well. The two manufacturers do not have compatible socket types. So once you determine the socket type, you have also predetermined the manufacturer. Power consumption, now that's a big thing because it depends on many factors. Number of cores, the technology that goes into the processor core are the two main factors. So I have to put that here too. It's called fabrication technology, or size of transistors. Are you specifying something that uses the 45 nanometer process, or are you specifying something that uses the 32 nanometer process? Okay, because that has direct impact to power consumption as well as the speed of the processor. We talked about cache. Okay, so you don't have to make the distinction between level 2 and level 3 cache. Most people only advertise level 3 cache anyway. Okay, when you look at it, like 4 megabytes, 8 megabytes, those are all level 3 caches. Okay, because level 2 caches are so tiny and it's all built into the processor core itself. A lot of times you don't see that specification. So I only care about level 3 cache, which is in the order of 4 to 8 megabytes these days. Memory speed. Okay, processor core these days directly specify the speed of memory it can support. Most cores today can only support up to 1600 megahertz transfer type of memory. But if you look down the line, Intel probably has announcements for processors that can talk to memory a lot faster than 1600 megahertz or mega transfer per second. So that's also one consideration. I would say that cache and memory speed together would have more impact on the performance of a system than gigahertz or even number of cores to a certain extent. Okay. And once again, the website that we looked at today at the beginning, that will show you the benchmarks of the processors. They will compare. You can see sometimes a dual core processor sitting right next to a quad core processor. Okay, just because the quad core processor is using the older technology and the dual core is using a newer technology. So that's also something that you can consider, is to look at that particular benchmark diagram, and then you can pick the processor. Once you no, that would be the one I made a link already on the cisc300 website. So if you look under the current topic, let me just double check and make sure. And I have to be careful not to go away from this link, because otherwise I'll lose everything. It's called Passmark Benchmarks. It's already linked from Moodle under the current topic.